So try to understand this topic. Common tangents to two circles. So you have to talk about common tangents, means it can be the count of common tangents, and also sometimes we have to find out the equation of common tangent between two circle and parabola, circle and ellipse, circle and hyperbola. So and also we will have other combinations as well. So in this part, we will figure out how many common tangents we can have while dealing with two circles. Okay. So here you have to understand two names. So it is direct common tangent. Okay. So what is direct common tangent? So if centers are on same side of line, it is direct common tangent. It is direct common tangent. Okay. Now you will understand this thing. Okay. Now we will have transverse common tangent. So we will have two types of tangent: direct common tangent, transverse common tangent. So what is transverse common tangent? So it is opposite of the previous one. If centers are on opposite side of line, it is transverse common tangent. I hope you understood the difference between direct common tangent and transverse common tangent. Now we will figure out the cases. Suppose we got this circle. Okay. Okay. Now look at this. Oh, I cannot have same length. Okay. So suppose that there are two circles, they are not touching and they are not intersecting. So how will you judge this situation? Because right now you guys have this diagram, but in examination you will have equation, so you have to deal with equation. Okay. So how will you judge? So suppose that this is center 1, this is center 2. So if I'll ask you to find out center and the radius of these two circles, you can do that. So you have to relate those two things only. Okay. Suppose that, like, I'm trying to correlate. Look, you know that what is this? This is the radius of second circle. What is this? Radius of first circle. Now just compare radius of those two circles and the distance between the centers. So don't you think that the distance between the center will be greater than the sum of radius? So can I say that R1 plus R2 is smaller than C1, C2, distance between the circles? So if you will fall in this case, now look at the tangent. Can we have a tangent this? Okay, like suppose that, please excuse me. Okay, so we can have one tangent this side, one tangent this side. Okay, suppose it is tangent, suppose. So you got already two tangents. Now you can also have this tangent. I'll draw smaller diagram. Okay, now look at this. Can we have a tangent? This is also the same case, but the size is different. Okay, So we will have one tangent this way, we will have second tangent this way. Okay, now third tangent, now fourth tangent. So if this is the case, we will have four tangent. Okay, now look at this. I am interested in direct common tangent, the count of direct common tangent, transverse common tangent. You know that direct common tangent centers are on the same side. Now look at this tangent. So if you will observe this tangent, the centers are on the same side. Also, if you will observe this line, the centers are on the same side. Now observe this one. One center is this side, other center is this side. So it is on the opposite side of the line. So this is transverse common tangent. It is transverse common tangent. So direct common tangent count 2, transverse common tangent count 2. I hope this situation is clear now. Okay. Now I'll go with the case 2, where circles are touching each other. Okay, like look at this. Look at this. These two circles are touching each other. Sorry. Okay. Now this is the center. This is the center. So center 1, center 2. Now look at this. Now look at the radius 1 and look at the radius 2. Don't you think that the sum of radius will be equal to the distance between the centers? So radius 1 plus radius 2 is equal to distance between center C1 and C2. Okay. So in this case, you will have this many tangents. Look at this. Suppose it is touching each other. Now look at this. Can we have a tangent this way? Can we have a tangent this way? Can we have a tangent this way? Now you cannot have tangent. More tangent than these numbers. So can you please tell me the number of direct common tangent? You know that center should be on the same side. Now look at this tangent. Yes, it is direct common tangent. Now look at this line. Centers are on the same side. Now look at this line. Centers are on the opposite sides. So the count of direct common tangent is 2 and transverse common tangent is 1. I hope this case is also clear. Okay. Now I'll go with other case, like this time circles will intersect each other. Okay. Now look at this. So this is the center of a circle. This is the center of second circle, C1, C2. Now look at this. Now please be super slow and try to compare. This is radius 1. This is radius 2. Now don't you think that the sum of radius will be greater than the distance between the centers? Correct? So can I say that C1 C2 is smaller than radius 1 plus radius 2? Okay. And the difference, if I'll talk about difference, so difference will be this and this. So difference will be smaller than, because this bubble, if you'll observe the bubble, the difference is smaller than the distance. So can I say that R1 minus R2 mod? So if you will fall under this case, you will have, look at this, first circle, second circle. So in this case, you will have how many tangents? Look at this. This is the first tangent. This is the second tangent. So you will have two tangents in this situation. Okay, and if you'll observe, both are direct common tangent. So count of direct common tangent is 2 and transverse common tangent is 0. I hope this situation is also clear. Okay, now I'll go with the next case. Now look at this. Suppose that we have a circle and this time circle is touching from inside. Okay, now look at this. This is center C1, this is center C2. So look at this. Now be super slow. Look at the idea. Who is this? The radius 1. Who is this? The radius 2. Okay. Now look at this. So can I say that the sum of radius will be always greater, correct now? But if you go with the difference of radius, R1 minus R2, look at this. Don't you think that the difference of radius will be equal to the distance between centers? Okay. Now look at this. How many tangents we will have? So the count of tangent will be only 1. Look at this. Only one tangent you can drop, which will be common on both the circles. So, and it is direct common tangent. Direct common tangent is 1. Transverse common tangent is 0. Is that okay? Now look at this situation. Suppose that this time circle is inside circle, no touch, no no cut wala situation. Okay, so what will happen? Now look at, either you will compare sum of radius, difference of radius, and you have to compare the distance between centers. So suppose C1, suppose C2. Now look at this. Now be super slow. You know it is radius 1, it is radius 2. So if I'll talk about the difference of radius, you will get difference of radius will we get this thing. Okay, and oh sorry, this cannot be the radius, this is the radius. Okay, now look at this, है ना? So difference of radius will be what? This and this. So don't you think the difference of radius is smaller than, means this difference is greater, difference of radius is greater than the distance between centers, correct or wrong? Okay, and in this case you will have no common tangent. Okay, I hope all situations are clear now. Okay, now we'll proceed with illustrations.